AMC 10A 2005, problem 19. Three 1-inch squares are placed within their bases on a line. The center square is lifted out and rotated 45 degrees. Then it is centered and lowered into its original location until it touches both the adjoining squares. How many inches is point B from the line to which the bases of the original squares were placed? The last sentence is very important. How many inches is the point B on the line from the base of the original square for which it was placed on? So that is not referring to this line right here, because that's not the base that the original square was placed on. The base it was placed on is this segment right here. Let's call this segment A. So we want to find the distance from B to A, and this geometric problem is very simple. A common thing to remember when doing geometric problems is to always remember your distance formulas and the Pythagorean theorem. So first of all, we know that every single square has a length or a side length of 1. So we know that this distance is 1. And we see here that it's overcounting this height of this little triangle that's peeking out. And we must also add the distance from B to its intersection of this line. So how do you do that? Well, first, we know that this square was rotated 45 degrees. So this square that's rotated will have a triangle that's a 45, 45, 90 triangle, because the angle of the square was rotated 45 degrees, resulting in this angle to be 45 degrees. Now, this is not a perfect model, but this is trying to convey the sense that it's a 45, 45, 90 triangle. And since it's a 45, 45, 90 triangle, and we know the hypotenuse to be 1, we can apply our trigonometric identity, or rather a property. So let's call this y. And since it's a 45, 45 degree triangle, this side length, the two legs, will be congruent to one another. So y will be equal to sine 45 degrees times 1, which is equal to root 2 over 2. And from here, what we can do is we can find out the height, because the height of this right triangle must bisect its base. So we have another right triangle as such, and let's call this h. The hypotenuse, root 2 over 2, and this will be 1 over 2. So h squared plus 1 over 4, half squared, will be equal to root 2 over 2 squared, which is 2 over 4, or 1 half. H squared will be equal to the square root of 1 half minus 1 fourth, which is the square root of 2 over 8, which is root 1 over 4, which is equal to 1 over 2. H being equal to 1 over 2. So the height is 1 over 2. Now, what is the diagonal of the square? Well, the diagonal can be found by the Pythagorean theorem with the bases to be 1. And that will be equal to, with this being h, or for the hypotenuse, h squared will be equal to 1 plus 1, h being equal to root 2. So this little height will be equal to root 2 minus 1 over 2. And from this, we can add it to 1, which is equal to root 2 plus half, meaning that the distance from B to the base A will be choice D, root 2 plus half.